In this little video, I'm just going to show you how to work with parallel and perpendicular lines as far as when you're considering a coordinate plane. So just like in a coordinate plane, we have 2 points. 2 points have determined one unique line. But between those 2 points and that line, on that line, you're going to have a slope. Some kind of a direction is where to go to get from one point to the other. So if you take a look at the parallel and perpendicular requirements, you'll notice that they have slope requirements. And the parallel lines aren't too bad as far as to visualize, because if they never touch, it kind of makes sense that their slopes have to be the same. You could prove that this must be with systems of equations. It's not so bad. But the other one, perpendicular lines, I personally have not, and I screwed this up. I personally have not proven. It can be proven. I just haven't sat down and figured it out yet. So if you ever want that, I guess I could, but I don't know how many hours it would take me. I like to do it myself and not cheat and look on the internet. Although it's not really cheating. Anywho, if somebody's already done it before, it's not cheating. It's just called standing on the shoulders of giants. Anyway, so these are the 2 different ways and the 2 different conditions you have. Essentially what you're going to get is you're going to get either a problem that implies it or a problem that specifically states this line needs to be parallel to this line or this line needs to be perpendicular to this line. When that happens, you choose which one of these conditions you need. Both conditions require you to know the slope of the line you're discussing. If you're watching this video and you are in physics or you have vector capabilities, there are other ways to do it, such as cross products in 3 dimensions. Anyway, so this isn't the only way. All right, let's go ahead and get started. Some of these are just simply check them out, see what happens. For example, find an equation for the line parallel to x equals 5 that passes through the point -2, 3. All right, well, x equals 5. Remember, in this case, the x value of every coordinate must be 5. But notice that y is not listed in this equation. That's because it doesn't depend on y. And the way I tend to explain it to my students is, imagine that you have an ex-boyfriend, girlfriend, whatever. Do you care what they're doing right now? And most people are like, no, not really. All right, well, neither does this. X equals 5. X is doing its thing. It's 5. What is y doing? I don't care. I just don't care. So y can do whatever it wants. So y could be 2. It could be -3. It could be 8. It could be 4 million. It doesn't really matter. So what you end up with is you end up with an x value that stays the same, which means because of slope is the change in the y's, how y changes, divided by how x changes. X is not changing. You have an undefined slope. There's no change in x. But y is free to do whatever it wants. So x equals 5 is a vertical line. A line parallel to vertical would also be a vertical line. Well, vertical lines always have x equals because x doesn't change. All we have to do now is look at the point that it needs to pass through and say, what is the x value of that point? That's it. We're done. So for this particular one, it's just x is equal to -2. That's it. That's all there has to be. In general, if you're working with x equals or y equals a number, but you're working with either horizontal or vertical lines, parallel means use the same letter. Horizontal or perpendicular means use the other one. That's really it. So as a demonstration of this, if we scroll down just a little bit more here, find an equation for the line perpendicular to y equals 3 that passes through the point -3, 2. Perpendicular to y, so y equals 3 looks like this, which means perpendicular is going to be vertical, which is x equals. But x is -3 in this case, so this is just going to be x equals -3. See, it's not so bad. It's not so bad. We'll see. Maybe it is. Maybe it is. All right. Here we go. Number 3. Find an equation of the line in slope-intercept form. So now we're going to get specific. that is parallel to the line 3x minus 2y equals 12 and contains the point 5, negative 2. Okay, so that's not the same as the others. So we're going to have to go through a particular method here. Again, reminding ourselves what parallel and perpendicular mean. Parallel means that their slopes are the same. Perpendicular means their slopes are opposite reciprocals of one another. Their product is negative 1. So, I'm looking for parallel. That means that I'm looking for the same slope, but I need to have the slope of the line. That's the problem. Here we go. Taking this 3x minus 2y is equal to 12. I need to find the slope. Now, there's several different ways that I could do this. Personally, if I'm dealing with problems of this nature, I find it the easiest to get it into slope-intercept form because whatever's in front of x at that point is the slope. Now, if you take a look at the slope-intercept form, it can help you reduce the amount of work. Because if you notice, the slope is only right next to x. Whatever this b thing is, we don't even care. It turns out that this 12, that's with the b. We don't care. I just don't care about it. So I'm going to completely ignore it. You can make it 0 if you want. It doesn't really matter. So 3x minus 2y is equal to 12. I'm going to add 2y to both sides. And then I have 3x is equal to 12 plus 2y. I'm going to divide both sides by 2. And now, while I'm actually dividing both sides by 2, again, I don't care about this guy. It's irrelevant. So I'm dividing by 2. I get the y by itself. The x is 3/2 x. This is going to be the slope of my line. It's like, Phil, you got rid of this stuff. Yeah, but that's plus 6, and then you subtract 6. It turns out to be a y-intercept. It's always that way. You only need to concern yourself with the stuff in front of the x when you're looking for slope. That's it. Everything else is nothing because it doesn't matter. All right, so now the slope of the line, of this line, is 3/2, which means the slope of the parallel line is also 3/2. We have a couple of different ways we could do this. One common way is to, because we have a slope and we have a point, is to use the point slope form. If you've never seen it in action, it looks like y minus y1 is equal to m, the slope, times the quantity x minus x1. Well, this is really undergoing a shift. I mean, that's kind of what's happening behind the scenes. And so this is for the slope of m and the point x1 comma y1. Notice that there's no negatives here. That's because these minus signs must be there in this format. Otherwise, it doesn't work quite right. So what this is doing is it's shifting the graph y equals mx. It's shifting it away from the origin, x1 units and y1 units. So it's up and down in y1. It's left and right in x1. If we just shove all this information in there, then what we find is that we have y minus the y1 is this guy, the negative 2. So y minus negative 2 is equal to 3/2 x, and in the parentheses x minus 5. Now to move on from here, I need to go ahead and I need to just kind of solve for y and expand everything out. Doing that, I get y plus 2 is equal to 3/2 x minus 15/2. If I subtract 2 from both sides, that's like subtracting off 4/2. So y is equal to 3/2 x, and that's minus 19/2. And that's it. There's our answer. It's the line parallel to 3x minus 2y equals 12 that passes through the point 5, negative 2. There's another way to do this too, if you don't like doing it quite that way. What you can do is you can put it directly into the slope-intercept form. Let me grab a different color here. Let's grab red. And we have a slope, and we know that a point on the line is a solution to that line. So we can use directly y equals mx plus b, the slope-intercept form, which is what we wanted in. We know a value of y that works, it's -2. We know a slope, it's 3/2. We know a value of x that works, it's 5. And we don't know what the y-intercept is. So we can solve for it. -2 is equal to 15/2 plus b. If we subtract off 15/2 from both sides, then we get this -2 minus 15. It's really -4/2 minus 15/2 for -19/2. That equals b. Okay, so now we have the value of b, we have the value of m, our slope. We just simply shove that right back in. So this is going to be y is equal to 3/2 x minus 19/2. And that's it. You can use either one of these two methods. That's perfectly fine. It doesn't matter which one. Neither one is better than the other. I prefer the point slope, but that's a personal thing. You can do whatever you want. It's no big deal. So, I mean, you know, if you have somebody that tells you just like you have to use, really? Does it work? Does it really work? Do you have to use steel on a bridge, or can you use wood? Can you use stone? The Romans would say stone because they didn't have steel like that. So, yeah, it can work. It's fine. It's okay. So anyway, we got the answer. Moving on. They can get a little bit involved. They don't really get more complicated. They just get more involved. So again, find an equation in slope-intercept form. Everybody loves this. I don't know why, but everybody loves to find the slope-intercept form. Personally, point-slope form. It's more general. For a line perpendicular to this thing. Okay, so now be very cautious here because we have two equations. We want to be perpendicular to this guy, which means we need slope out of him. So we need our slope. But we're going to have the same y-intercept as that guy. So we need his y-intercept. All right. So here we go. Let's find the slope. 7x plus 3y is equal to 5. And we want to find the slope, which means I only care about what's happening with the x. And again, a different way, you could find 2 points on this line, shove it into the slope equation, and be done. I think it's a little easier to do it this way, but if you don't really care for fractions, that's a way to do it. So just make sure you choose the right numbers that give you good numbers. Okay, here we are. So we're going to subtract, oh, I don't want to do that. I want to subtract 7x because I don't want to divide by negative. That's a personal choice. So we have 3y is equal to 5 minus 7x. I divide both sides by 3. That's going to give me y is equal to something I don't care about, but I'll put it down anyway, minus 7/3 x. This thing in front is what I need. Okay, so now our slope for this line is -7/3. But if you recall from up at the top where we had down the definition of what it meant to be perpendicular, m1 is equal to -1 over m2, or vice versa. It doesn't matter. So, you know, just replace the m1 and m2. So what we're going to look for is the opposite reciprocal. We're going to flip it and change the sign. Change sign. So -7/3 becomes +3/7. This is the slope of our perpendicular line. Slope of perpendicular line. The upside down capital T means perpendicular because this is a right angle. Perpendicular line. Okay, so now we got that little piece of evidence. What we're going to need now is we're going to need to jump over here and we're going to need to find the y-intercept of this. A couple different ways you can do it. Number one, you could solve this thing for y and you have it in slope-intercept form. When you do that, whatever number's at the back end, that's your value of b. That b would be being put right in here to the slope-intercept form. An easier way for me, remember that the y-intercept occurs at 0 comma something, which means x is 0 always for that y-intercept. In that case, 3 times 0, I can just put in 3 times 0 is equal to, minus 4y is equal to 7. That whole mess goes away. What I typically do is if I'm doing it on paper, I'll take something like that and I'll say, oh, well, I'll just cover that one up. I realize this is not x, but I'll just cover this up and then I'll just divide. I don't even go through all of this stuff. I just, and there it is. So I have to electronically cover it up. And now I have negative 4y is equal to 7. I divide both sides by negative 4. And my corresponding y value is negative 7/4. Now I have my y-intercept at 0, negative 7/4. And I have my slope of positive 3/7. So take those two pieces, this guy right here, that guy right there, bring those together, and what do you get? Y equals 3/7 x minus 7/4. And that's it. They don't have to be nice, but yeah. If you run into a question where you have, it says find an equation that passes through these 2 points, or parallel to these 2 points, or whatever it says, go find the slope, then use either of the points. It doesn't really matter. It doesn't. Both points work. So just open your mind. Understand that the only thing that you really need to know is the slope. After that, things fall out depending on the problem. But parallel slopes have the same slope. Perpendicular slopes have their slopes product. If you multiply the two slopes together, you get -1. Always. Always and forever. Amen. All right. I hope this helped y'all.